Yeah, thanks, Cameron. So that was a great intro for the 1 week and a little bit more about 1 week. Um, so our focus is getting familiar with Python and then using the tools to make a data dashboard. Now, data dashboards super useful, super helpful for providing data insights. Like if you just Google COVID-19, you'll see a bunch of summary statistics like over time of the trends of COVID, or for marketing, if you want to understand like internal business metrics, you'll have all these figures representing the internal business metrics. So I'll hand it over to my team to talk about the data dashboard that we made. So Varun, whenever you're ready, go ahead.
The data set that we used was like US car accidents from 2016 to 2021. So the data set consists of hundreds of thousands of accidents that occurred in the United States. Each accident has a variety of information stored in it, from the location and the conditions to the severity of the accident. Most of these figures were created on a smaller subset of 20,000 for these accidents, but a few used a larger subset of around 340,000. The data was analyzed to determine the factors that caused the accidents, and then further analyzed to determine what factors influence accident severity. The data set was created by Mosavi et al. So our first section here is one that shows the accident statistics and the conditions that occurred during an accident. It is more likely to get an accident driving at night. How does location affect an accident? And these questions, maps, and charts were helped created to understand this. So the first chart we have here is basically just we tallied up all the accidents that occurred in each state, and then we figured out how many accidents occurred in each state. So to analyze, the goal of this was to try to figure out what was the most dangerous state to drive in. So in this chart, we have California with the most number of accidents, but this is slightly misleading because states like California have a higher population and thus would get a higher proportion of the accidents. So we created a relative number of accidents per capita in each state. And so what this does is it ranks all the states by like the relative per capita, so this by person. So a state with a higher population doesn't necessarily have the highest per capita of accidents. So with this, we can see that California wins the title of most dangerous state to drive in, with Florida coming in at second place with 86% of the number of accidents of California per capita. So this graph, compared to the previous one, more accurately represents the relative chance that random person will be in an accident. And then we have one more graph here, and this is just we counted by county, and we have just as a trend, we see that accidents, bigger cities tend to have more accidents because there's more cars and there's more people that are driving.
Yeah. Okay, so the next chart we have is surrounding characteristics of accidents. And as you can see, this pie chart represents surrounding environments of an accident. And these statistics can include one or two different types of labels. For example, people may have gotten in an accident by an amenity or also a stop sign. And then if you're kind of confused at what is which, you can just go to the website and it goes into depth which each is. And then most accidents appear on crossing roads, traffic signs, and stations. And then the next pie chart we have is time of car accidents. And this represents the time of the day most people have gotten into a car accident. So, and then the evidence from this pie chart shows that most accidents happen during the day.
All right. In this next section, basically, we explored the severity of accidents and factors that contributed to such said severity. Things like, does the state an accident happen increase the likelihood of getting in a more severe accident, or precipitation, and how distance is affected by severity changes, things of this sort, because basically it allows others to be more aware of the dangerous conditions. In this figure, you can see that location is represented by latitude and longitude, and the severity is represented by the colors. This figure shows that most severe crashes occur in central to east coast rather than the south coast and western coastal parts of the US. This possibly could be due to the fact that the East Coast has nearly double the population of people than on the West Coast. This next figure represents the average severity per precipitation level. It was expected that the severity increases during higher levels of precipitation. However, the actual opposite trend was seen. This could be due to less people driving during increased rain and people driving more carefully. This next plot is a multi-box plot that represents the temperature ranges at a severity level. It is observed that larger severities are typically in colder temperatures, and there are multiple reasons why this could happen, one of which could be like there's ice on the road. And for our last figure, it is another multi-box plot that represents the distance of traffic affected by an accident severity. It is seen that for larger severities, more distance is affected. This means that there is more traffic buildup in these larger severity accidents.